Hello, this is Dr. Mears. Today we are going to be learning about geometric sequences. Take a look at this picture and just ask yourself, what do you notice, what do you wonder? Let's delve into the picture a little bit more. We are going to complete the chart using the picture from slide 1. So stage number 1, there was one person that was newly infected. So this is stage 1. Stage 2, we have 1, 2. Stage 2, we have 2. Let's see how many we have in stage 3. Stage 3, 1, 2, 3, 4. 4. Stage 4. Stage 4. Stage 4. Let's see how many we have. 1, 2, 3, 4, 5, 6, 7, 8. We have 8. Okay, so as we increase in stage number, we also increase in number of newly infected people. So let's take a look at just the number of newly infected people, just that pattern of numbers. What do we notice? What do we wonder? Well, my notice was that every time we increased by the stage, we were multiplying the number of newly infected people by 2. One person went to 2 people in that line. One person went to 2. Okay, and then when you had 2 people, they infected 4 altogether. Again, times 2. 4 people infected 8. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So we're just looking at this pattern. We find it has a common ratio of 2. Okay, this gets us into arithmetic sequence versus geometric sequence. We saw in an arithmetic sequence, we had common differences, whether we're adding or subtracting a common number. Geometric sequence, we have a common ratio, whether we're multiplying or we could be dividing, but I would like you to multiply by a fraction. So what is the difference between the two? Arithmetic sequence. Oops. We have a common ratio. Nope. Dr. Mears, that should be common difference. Thank you, everyone. And our common difference, we added, subtracted. A common number. Okay, in a geometric sequence, we have a common ratio. And in a common ratio, we multiply. We can say divide, by a common number. However, this divide, I want to say multiply by a fraction. And I'm going to show you that in a minute. Okay? Add or subtract, multiply by a whole number, or multiply by a fraction. Let's look. Here's your definition. Geometric sequence has a common ratio between each term. Here are some examples. We saw 2, 4, 8, 16, 32. So what are we doing every time? When you have to find the common ratio, and I gave you the answer, common ratio of 2, but when you have to find it on your own, I'm going to give you a little hint. What you should try is you should take that second number, which is 4, and divide it by the first, which is 2. That's going to give us a number. That's going to give us 2. So we know automatically this was times 2. Well, let's try to see if when we multiply 4 times 2, if we get to 8. So let's try it. 4 times 2 is 8. That's true. All right, does it work for this one? Is 8 times 2 16? Yes. Does it work for this one? 16 times 2 32? Yes. So every time we are multiplying by 2, and it's coming out to have a common ratio of 2. All right, next one. 80 to 40. Okay, what do we have to do to 80 to get to 40? Well, again, we can just simply divide the second number, 40, divided by 80, and we come out with 0.5. Now, you are more than welcome to work with decimals. However, I'm going to show you a little hint. If we press the math button, we see this 2 fraction here. So you can press enter, and it's going to ask you, do you want to put this in a fraction? And you're going to say yes. And it will come out with the fraction of 1/2. I really like that feature because it now allows you to work with fractions. So for this one, I really had to multiply by 1/2, or split 80 in half. 80 divided by 2. So you can say that. You can say that we divided 80 by 2. However, I want you to write it out as times 1/2, please. All right, 40 times 1/2 gives us 20. 20 times 1/2 gives us 10. 10 times 1/2 gives us 5. So we have a common ratio of 1/2. It does mean we did divide by 2. However, when you make a common ratio, I do want it in that fraction. All right, number 3. Let's find that number that we have to multiply by 2 to get to -6. So we have -6, the second term, divided by the first, which is 2. That gives us -3. That's different. So multiplying by a -3. Well, this makes sense because if you look, we have a positive number and a negative number, positive number and negative number, positive number. I'm sure the next one's probably going to be negative. And so this multiplying by this -3 flips the negative to a positive and then the positive to a negative. So that does make sense. All right, well, -6 times -3 does get us to a positive 18 because a negative times a negative is a positive. 18 times -3 gets us to 54, -54. And -54 times -3 gets us back to a positive 162. So we have a common ratio of -3. You may write these out using the letter R. Common ratio of 2, common ratio of 1/2, common ratio of -3. That's a letter that we're going to denote common ratio. Your turn. Okay. For these, we have to go and find our common ratio. So in your slide deck, I actually said, divide the second by the first and then see if it works every time. You have to see if it works. You can't just stop at this and say this is the common ratio. We have to make sure it works all the way through. All right, so we have to get from 3 to 9. So we take that second number, 9, and we divide it by 3. That gets us to 3. Okay, so we're going to believe that the common ratio is 3. So this is times 3. Well, if we multiply 9 times 3, we get to 27. What's the next number here? 81. This is really times 9. Do we have a common ratio? No. So no common ratio. Doesn't have any. I tricked you on the first one. Okay, I promise we're going to have common ratios from here out. I just wanted you to make sure that, when you find that first number, it doesn't mean that it could be common. I could trick you there and say that it doesn't have any. So this is not geometric. Because it doesn't have a common ratio. All right, let's try the second one. Let's see. Okay, so we have 960 to 240. All right, so let's take that second number, 240, and divide it by 960. We're going to come out with 0.25. Again, decimal is okay, but let's press math, enter, enter, and we'll be able to turn it into a fraction. So math, enter, enter, 1/4. Excellent. So this is times 1/4. So what we're really doing here is we're dividing by 4. Times 1/4 is the same thing as dividing by 4. So 240 divided by 4, or times 1/4, does give us a 60. 60 divided by 4, or times 1/4, does give us a 15. So this, in fact, really does work. And if you can't see it, I'm just saying 960 times 0.25 is going to get us to 240. 960 divided by 4 is going to get us to 240. 960 times 1/4 is going to get us to 240. The correct way to write it when we're working with geometric sequence is this way right here using that fraction. Okay, let's look at the next one. We have negative 1, positive 1, negative 1, positive 1. Oh, I bet you the common ratio is going to be negative. So we are going to take this second one, 1, that's positive 1, and divide it by, don't forget the negative button is down here, dividing it by that negative 1. I'm thinking this is going to be negative 1. Yes, that's one of those. So times negative 1. So let's look. Negative 1 times negative 1 is 1. Positive 1 times negative 1 is negative 1. Negative 1 times negative 1 is positive 1. It works for everything. Our common ratio is negative 1. Finding the nth term. Just like an arithmetic sequence, we wanted to find what position a number is. Is it the first number? Is it the second number? Is it the 12th number? Is it the 300th number? So in geometric sequence, we're going to be doing the same thing. So let's try. A geometric sequence has first term 3 and common ratio 2. Find the 10th term. Show work below. Now, I haven't given you a formula yet. I wanted you to try this on your own. I wanted you to think about it and see our map of our numbers and really what we're looking for. So they gave us the 3. That's the first number. So the first term, which is the first number, is u sub 1. So they said that u sub 1 is 3. They also gave us the common ratio, r, and they said that was 2. They want us to find the 10th term, so we need to find u sub 10. We're going to be using the same u sub 1, u sub 10, just like we did with arithmetic. The difference is going to be the formula, and that we're using now r instead of d. All right, let's see what this looks like. So they gave us the first one, which is 3, and they want to know what is this 10th one. So we should fill in all the numbers here. This is the longer way of doing it. Common ratio of 2 means every time we are going to multiply by 2. Wow, that's a lot of multiplying by 2. So when we do this, let's try it. So we're going to get 3 times 2, 6 times 2, 12 times 2, 24 times 2, 48. 48 times 2, 96 times 2, 192 times 2, 384 times 2, 768 times 2, 1536. Wow. That is a lot. So we had to multiply 9 times. Oh my goodness gracious. So let's see what this formula works out to be. We know it's probably going to have to incorporate the first term because it has to incorporate where we start. The formula also has to incorporate our actual ratio as well. So let's go through and see how many times we had to multiply. So we want to find the 10th term. Okay. We started at 3, and we know that we have to multiply. And we're going to be multiplying by our common ratio. So every time we had to multiply by 2, multiply by 2, multiply by 2. But we're not just doing this one time. How many times did we have to multiply by 2? 4, 5, 6, 7, 8, 9 times. So we have to do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you still see on the screen? Yes. So how can we rewrite this in a way where I'm not rewriting 2 all these times? Because this is only the 10th. Imagine if I had to find the 20th. That would be a lot. So we know right here there are 9 2's. So we can say the 10th term, okay, we have to multiply. If this is the first one, that's where we start. That's where we started multiplying. Times, we have our common ratio. That's the number we kept multiplying by. And we had to do it 9 times. That is an exponent. When we have to multiply by itself is an exponent. So we have to multiply 2 by itself 9 times. This is now the derivation of a formula. Our formula, if you want to incorporate the 10, equals 3, 2 to the 10 minus 1. because 10 minus 1 is 9. I'm wondering if this is going to work for everything. And yes, we just found the geometric sequence formula. Yay! So here's the term number. That was our u sub 10. Okay, equals. This was the first term. Our first term was 3. Okay. This is the common ratio. Our common ratio was 2. All right. This is the term position, and then minus 1. 10 minus 1. And the reason why we have to subtract 1 is because we actually, remember, had to only multiply 9 times. We had to multiply 9 twos. Multiply by 2. Multiply. We had to do that 9 times. So we just want to make sure that we have that term number minus 1, because that tells you how many times we have to multiply it out. Yay, we have a formula so that we don't have to write all of those 2's out, especially if we were going to find the 30th. So let's try using the geometric sequence formula. The geometric has first term 3, common ratio of 2, find the 10th term. So I'm just now showing you the process, exactly what we went through. This is no different. This is just another way of looking at it. So u sub 10 is what we're looking for. Here's our first. Here's our common ratio. Here's 10. Here's our formula. I put the 10 in where the n is, the 3 where the first term is, and the 2. And I like how I put my parentheses around this. It keeps my common ratio together. If we have a fraction here or a decimal, it's going to be nice because we have those parentheses. So we do our parentheses, make sure we do the exponent first. Now we can multiply by 3, and we find that our 10th term is 1,536. Now I'm going to tell you a little bit of a shortcut. If you would like to, in your calculator, do it from this step right here. 3 times 2 and parentheses. Put the parentheses in. The parentheses represent multiplication. Here is your exponent button. This caret is your exponent button. It's right above the division. So it's really nice because they're all here. Addition, subtraction, multiplication, division, exponent button. Okay. So we press the exponent button and it raises it. We can put 9 in. Enter. There we go. We don't need to use the order of operations here. We can put it in our calculator. This eliminates a lot of the mistakes that you might make in these little steps here. Okay. So on to trying some. It's our turn. So what I want you to do is use that formula, substitute your numbers in, and try to find each term that they specify. And yes, I am going to show you the answers. I will not be doing these all out right now. I'm going to be setting up the page. Here we go. Okay. Bringing it down so that everybody can see. There we go. Adjusting camera. Sometimes it takes a little bit. Okay. So we have the geometric sequence formula, and we also have, making it perfect, number 1. Okay. There was number 1. U sub 1 equals 5, R equals 4, and we need to find U sub 12. So what I did is I first substituted everything into the formula. Please notice how I put parentheses around the 4. And then there's my 12 minus 1. Next, U sub 12 equals 5, 4 to the 11th power. In my calculator, I did not bother doing any more order of operations. In my calculator, I put down 5 parentheses, 4, end parentheses, raised it to the 11th power. And I received this massive number, which is correct. So our number that we have here is 20,971,520. Okay, let's go to the next one. The next one, number 2. And please, you can always pause. So if you wanted to pause on that work to write it down because you didn't understand, absolutely fine. Don't forget to be able to pause. So number 2, U sub 1 is 5, our R is negative 5, and we have to find U sub 6. Again, I put it into the formula. I subtracted 6 minus 1 and got 5. Please notice how I put my parentheses. This is holding the negative together. So when I do 5 parentheses, negative 5, not forget, remember this is the negative down here, and then to the, I believe it was 11. Nope, was it? Oh, sorry, it was complete 6, 5. I'm really messing up here. 5, okay. So, and there's our answer. So make sure you put the parentheses around that negative, and that was my answer. So there's number 2, if you would like to pause. All right, number 3. Here's number 3. We have now, the first term is 32, the ratio as 1/2, and we have to find u of 11, sub 11. So here we have 32. Notice I put the parentheses around the 1/2, 11 minus 1. And I'm going to show you this in the calculator because I want to show you what happens. So I put the 32 parentheses, and then I'm going to do 1 divided by 2, end parentheses. That makes it a fraction. That makes it 1/2. The simple division sign makes it the 1/2. Exponent button to the 10th power. We now have a decimal. That's the right answer. That's the correct answer. The light was on there, I'm sorry. That is the right answer. That is the correct answer. However, I would like you to change it into a fraction. So you have to remember, you can press math. It asks you, yes, I want to turn it into a fraction. Enter, enter. And here is our fraction, which is 1/32. Now I wrote that out for you. So again, if you would like to pause it right there, there is the work. And so I even wrote down math, enter, enter for you. That is the right answer, but 1/32 is a really nice answer. It's nice and compact. So don't be afraid to use those fractions, especially because you now can change a decimal into a fraction. Very easy. All right, let's go to number 4. Here's number 4. We have the first term is 2, ratio is 3, and we have finding the 7th term. So we put it into our formula. We have u sub 7 equals 2 times 3 to the 6. Using the calculator, we're going to get 1458. And again, you may pause it. All right, going on to number 5. Please notice the first term is 11. We have a common ratio of -2, and they want you to find u sub 18, the 18th term. Now that we have a negative, we have to be careful because when we put it in, again, our parentheses are going to help us keep that negative with a 2. And then I'm going to do in the calculator 11 times the quantity of -2 raised to the 17th power. And I'm going to get, putting my commas in, negative 1,441, 792. And the last one, this is everything in it now. We have a first term of 54. We have a ratio, negative, and a fraction, -1/3. And we have finding the 10th term. Substituting it in correctly, please put those parentheses around the -1/3. In the calculator, you can do 54 parentheses -1 divided by 3, and parentheses to the 9th, and you're going to get this big decimal, negative 0.0027434,842. I would love that in a nice compact fraction, and again, you can press math, enter, enter, and we come out with the 10th term as -2 divided by 729, and that is a beautiful answer. This has been Dr. Mears with Geometric Sequence. I hope it helped, and please make sure you go back and review any part of this to hopefully understand the concept fully. Thank you.